We have them in the group chat of the team.
Awesome. So just pull up the group chat and show us the findings you guys had, okay? And let's discuss with the other teams, you know, if that was something that they also found or something they didn't solve, okay?
Okay. So let's see if we can show that. First one. I want to talk about this one first. Probably all the teams here found this one. It's a very common one. It seems like it's the. Do you hear me, boys?
Yeah.
We can hear you perfectly. Can you make this the code screen full size? Yes.
Yeah. So the first thing is.
Can you make the font
function,
a little bit bigger? I think Control Plus.
Yeah. Oh, it works. You see that?
Yeah, it's good.
Yes.
Okay, so the first one is the mint rebalancer and the burn rebalancer functions. Very common one, literally next to each other.
This
Burn and
is
mint are freely
Sherlock,
accessible
right?
by anybody. Yes,
This
is
what
Sherlock.
USD
contract.
on Sherlock, right? Okay.
Yes. So as you can see here, the function mint rebalancer and burn rebalancer are both non-protected, and they can be accessed by anybody just by calling this address and putting any amount they want, directly impacting the amount of the contract has. On the top of that, this is Uniswap v3 contract, if I'm not mistaken, which means that if you can influence one of the tokens, you can influence the price in the pool. Somebody can correct me if I'm wrong, but that's what my understanding is from that. Obviously, you can burn all the tokens here as well, so that's a direct
I have
impact.
one question regarding these functions that are unprotected. Aren't those being inherited by another contract and overridden into a protected function?
No, I thought that as well, but I searched everywhere, but apparently they implement that by. Let me open the contract; it will be much easier. Oh no! Sorry, boys, I clicked the wrong one. I meant with code.
Just one question here. Did they use truffle in their code base?
Yes. I do not understand truffle, so I cannot really speak about truffle. So yeah, they inherited that. I think from here. I know it's from OpenZeppelin, but I'm not sure if it's here or the safer one. Let's see, actually. Check that really quick. If it loads, that is. Okay, that's one open. Yeah, that will be. Let me find it for you guys. That will be this function. As we can see, I can set that for you. It's not being defined anywhere. It's just being pulled directly from the other contract is this one, and it doesn't even have the function. So I checked them deeply, and it came from one of the OpenZeppelin ones. That was one of the problem. The other one is give me a sec, because yeah, they're talking here. I don't know how to remove it. No. because I have other people wanting to see that as well. Does anybody know how to? Ah, there we go. So, bro, can we? Yeah. The other one we found is this function initialize, which I don't know how much of the teams found that. Basically, the function is a function and can be called by anybody. Usually, they copy paste it from OpenZeppelin, the function, but on OpenZeppelin, this is internal, so it can be accessed only by the contract. Here, it can be accessed by anybody, and anybody that accesses this function becomes the admin directly by just interacting with the function. Obviously, it means to the message sender. My thoughts initially was that the developer was thinking that how to say that this is gonna be initialized only once, and that's why they put the admin to create the initial pool. But apparently they were meaning to do that, I think. I'm not really sure.
But what about the initializer modifier? Doesn't that prevent this function to be called twice?
Apparently no. I'm not really sure how initializers
Yes, it does.
completely
So
work.
if it's OpenZeppelin implementation, it does. This initializer makes sure that
but
you
it's
can
not.
call it only once. Sorry?
But it's not. That's the thing. It's a function they create with the name initialize. If they implement it directly and it's actually
I see now.
if it's
Can we look at the
it's like
code?
that, then I agree. But it's a function.
No, but actually, this is how the proxy works. So if you have proxy and you can't run constructor on your new code, this is what is standard and what people do usually. They are creating this initialize function, which is like or either public or external, and
it would be external in that case, isn't it?
yeah. So if there is possibility to call it like internally, then probably it won't work as well because this initializer modifier is setting up the lock that it can be like created only once in given contract. If you're like changing proxy implementation, then you can do that, but otherwise, like you can't really. So
yeah, because
yeah, I don't know. Maybe I don't see something here, but it looks like the standard proxy initializer.
yeah, but here I found because I checked on the judge really quickly to reconfirm our thinking, and they uploaded a POC with exactly that function, and the POC confirmed that the attacker became the admin.
Okay, so they messed something up. Okay.
Yeah, I think they implemented their own initializer. I would like to see the code for their version of initialize it.
Exactly. If they implemented it from OpenZeppelin and they used OpenZeppelin, it would be completely fine. It would be perfect. So yeah. Even here you can see they recommend to use the OpenZeppelin initializable.
Really nice, guys. This is really a really good meeting for us to have.
And there was one more we found. The other one is it should be in findings, which is this one. If I'm
The Oracle manipulation.
Yes. So the DIE Oracle over here actually gives wrong address. And the funny part is, it was pulling the price from completely different pool, and then it was depositing to this one, which was very strange. And obviously that's like giving completely different price for what you're gonna get. So basically that's our three findings.
That's Scarlet team, right?
Say again?
This is Scarlet team, right? Scarlet Hawk.
Yeah, right.
Yeah, this is the Scarlet Hawks, yeah.
Guys, really nice. Okay, you guys did a fucking really good job. The only thing was the submissions, but that won't happen again. Let's just forget about this part. And does
Yeah, no worries. It's
anybody
like
from other teams found the same things? Delirious, 3D, Bean.
So we didn't participate in this contest. We did juice box.
Okay. Anyone else did USD SD and found the same thing? Let me see here. Who are here? Carno, I don't know what his team. A-Beans, what is your team? A-Beans, you're not in any team. Alex just got into Hidden Spider. Yeah, Azarian. So yeah, I guess let's go to Delirious team and let's look at their findings.
just before we summarize, before we end the talk, we also found a problem in the other one that they just mentioned, the juice box. I don't know if you want
Yeah,
to.
let's take a look. Let's take a look at that.
Because I don't really know how it really happened. Because that guy team found it with he customly tested it with Foundry. I think it was something about the square root of 96, that function. If
Do you
guys
have
know what
any
I'm talking
code
about.
snippet that we can look at? Do you guys have this on GitHub, on the rich repo?
Search team's name on search, and you can find what he submitted.
Oh,
On
yeah?
yeah. Search what he typed. Yeah, the first one.
It should pop up.
Yeah, look at right.
This one. It's this one.
Okay, yeah, jump there.
No,
that.
why is it not showing me?
Jump, yeah.
Oh, there.
Awesome.
It's this one.
So fuzzling
I
these
didn't
breaks
really
every
get.
time.
Yes. I guess the other people that will talk about this contest now will give us some more light about this function here, because I didn't really go deep on the juice box contest. So yeah.
Interesting. So why does it break?
I don't know, but I tested it myself as well, because he put it. Actually, that's the function itself. I put it in Foundry. I think it's already installed, so I can just literally run it for you to see. If I found
Isn't that under the function you typed in the Discord?
You
Yeah,
mean
yeah,
this one?
Yeah.
The square root. Yeah, I actually put that in my one as well. So I'm gonna just run it for you, if it saved my file, that is. Delegate it to. Oh no, delegate unit I put here. So yeah,
Is it possible it's breaking because of lesser than UN256, like UN160 for square roots?
I'll show you now, boys. Because for the people that understand better than us, I'm still learning boundaries. How many V's you want, boys? 2 or 4?
3 is enough.
How do you? 3?
Yeah. Let's see with 3 and 2, maybe.
1 sec, 'cause my code freezed or something? I don't know.
Yeah, it happens. I
No,
say 3. Oh, damn. I say 3 because
it's my
4 V's returns even successful
much.
tests. Yeah.
There's
I see.
a dash.
Yeah, so.
Still before the test, there is a dash.
Say again?
Like you need
Before
to
the
type 4
test,
tests.
there is a dash.
Yeah, but
I think 2 dashes,
I want
right?
it like that.
No, it should be
No,
forge space test. without dash.
Yeah.
Without the hyphen. Just remove the hyphen.
Delete it.
Yes.
You mean that?
Yes.
Yes.
Yes,
Ah.
exactly.
Yes. Let's see, boys. Yeah. I'm telling you, I'm still learning. I started learning this like 3 months ago, 3.5. What do you mean? Very much. There we go. Now it should be fine. There we go. And let's find it. It's this one over here. For data.
Yeah, I think it was because of uint 160 because it says not satisfied uint, but maybe I'm wrong.
Yeah, I don't understand the function, so if somebody knows exactly what's happening, can...
I think it's 0 and it needs to be greater than. So 0 is not greater than 0. Where is it asserting that? Is it at the end? I can't see the code. Yeah, price is 0.
Yes. Because this is a test, obviously. So. I can put amount if I'm not mistaken. And it should run like any. It should literally fuzz it to the... I'm not really sure about
I
that.
think you have to save
About
it.
PANDA.
Save the folder.
Awesome.
Oh, yeah. True. So it comes to the... As long as you just commit, it's fine.
Wait, you need to commit to run forge? Oh, fuck.
Yeah.
But
otherwise it gives you the same thing.
Why is it uint 160? Isn't it supposed to be 96?
Isn't it because of an address?
No, it's square root price x96 means that you have 96 decimal places. So you have 160 normal places and 96 decimals. So it adds up to 256.
Oh.
Yeah, this is how Uniswap v3 does that.
Damn.
Oh, wow.
Uniswap v3 has more alpha
Yeah,
than
this
I
is...
expected.
This...
I just want to make one commentary here. I think I would never be able to write that test. You know, it looks very beautiful. So you guys are actually making some calculations in there to match the price on USSD, right? This is great. Great work by
basically,
team.
yeah, but this is all team. This is actually all team.
I think I wouldn't be able to write this, you
know. I thought the same, but I started learning Foundry now, and the more I learn it, the more I feel confident that I can do it. But obviously, I'm still a newbie, so yeah.
Plus, like, it's just small steps. Like, you just build out one part of the function that you can understand now, and then the next day you build another part that you can understand. And small steps, that's all.
Yeah, it's like a language. That's what I tell people. It's like I
there's
treat
also,
it like language.
There's also the possibility that he used autopilot on that, right?
Or ChatGPT straight up.
But beautiful work, and that doesn't matter.
Yeah.
Sorry guys, maybe I missed this, but could you like give a bit of context of what are we testing here?
The square
This
root
is the...
function. Yeah, go ahead, bro.
It's better if somebody else explained it because it would understand the function better than me.
The square root function wasn't working, basically. So we were trying to figure out what was the problem, like what, from our understanding and the code that we can see, why is it not working as intended? And we brainstormed between uint 160, between assert price 0. Pretty much that.
Yeah, on price 0, let's put a 4V just to make it more detailed. It fails the first test. So sorry. Need to
Which part of
yeah.
the project used this code? Like, was when paying some staking, or what was the process behind the calculation?
If it's for square root, which is like Uniswap's library, I think this is where you include or like the protocol itself includes its tokens for liquidity and concentrated liquidity protocols. Like
Awesome.
basically, yeah.
like how
It would be
Fade
was
does.
yeah, basically. If
I haven't
I can find it to show there.
read this. I haven't read this, so I'm just speculating. For
It's this or the pool. Yeah, it's the pool. You're correct.
Really
It's
good
actually the pool.
speculation, bro.
Thank you.
Yeah, that's very nice, bro.
Awesome. Let's go. I want to see the leaders team findings. Okay, but really good job, Dark. Beautiful to see.
Thank you. I don't know how to go back.
Or better. I don't know. The leaders are Chris. You guys want to go show Chris? You want to show Red Lotus a little bit of maybe Engine Layer and Ninja?
I haven't set up the whole environment yet, and we might need to do it a bit.
No, you can. If you want, you can just scroll on Discord and show us the chat, and we can just take a look at that, like we were doing right now with our friend Dark.
Yeah, just give me a second.
No problem, bro.
So bro, Misanthropic. I'm Moonman from earlier. If you don't mind giving me the roles for my old accounts, and I
Nice,
went
bro.
ahead and left. Yeah, thank you.
But now you're back.
I left with my old account because I just purged that one. Like it was.
Let me see. What is your new account?
I'm Owl.
Oh, Owl. Cool.
Yeah.
Cool name.
Thank you.
What about Mohab? Mohab is too quiet today.
I haven't spoken, man. I haven't spoken a lot.
Wow.
Yeah, you're too quiet, man. What's happening?
Because when the experts are doing their job, I like to observe so I can learn.
Experts.
Smart man.
Yeah, man. Come on. I mean, a lot of the guys
I feel the same. Mohab, I feel the same.
And now expert, bro.
You are much skilled, guys. Come on. I'm gonna be honest.
I feel the same, bro.
I'm glad to hear that there's experts here, so that
guys. Sometimes
sometimes
they think that I'm talking out of my ass, just to talk. But
I just talked out of my ass when I said the square root function works with Uniswap v3 and it fits. I'm surprised I speculated right. I like
Yeah,
this.
but you see, our mind is like that, He has the information, but it's not well formatted.
I feel that I'm really behind.
It's fine. We'll never learn if we don't ask questions.
Yeah,
so,
that's true.
No dumb questions here, guys. Let's keep that as a rule.
Someone else that I'm also really happy to have on board is 0x. We are gonna make it. He's a really smart guy, really engaged.
Wait, so we're all gonna
I
make
also heard really good things about
Yeah.
Bing. Bing is a really good developer. Breeze is a really good researcher. Delirious is a fucking shad.
Yeah, man. Delirious is killing it. To be honest, he's taking care of us.
Good. Everybody, guys. You guys are good. A huge team.
Come on, Delirious. Come on. I'm gonna be honest, man. Big shout out to you. You're taking care of us.
The leaders the other day, people were discussing this thing on Twitter about precompiles, and I think Philogy was asking why precompiles. And in my head, the reason why we have precompiles is because they are expensive to process on chain, right? It's not about, and also it adds to the client security side because I have different implementations of precompiles. And yeah, I mean, it's too heavy to calculate those things on chain, right?
Yeah.
there was also this other thread about precompiles and like how there was a lot of protocols that used this or maybe misused it, and like including what specific functionality their protocol needed. And the issue with that is it wouldn't even go on like 2 or 3 years without the functionality that is now a precompile in Ethereum is already outdated in the protocol that's implemented. Since one of the examples was Zcash, they wanted something to allow atomic transactions from Zcash to ETH, and now the hash functionality that they added is outdated in Zcash already. So we're stuck with its precompile, even though it's completely useless.
Yeah, the problem is that if you add something to blockchain, you won't be able to delete it anytime. I don't know if you saw how the, for example, Go Ethereum or any EVM client is being built. You have to do this, you know, acrobatics, just verifying which block are you at, and depending on which block are you at, you are using different functions. So for example, there is one specific block which is the DAO hack, so it is hard-coded in the code. So if it's this block, yeah, do this, and yeah, we will stay with it forever, because any new node that connects to the network, to the Ethereum, now has to go, like, ideally go and verify all the blocks themselves. And in order to do that, you need to have all this legacy code in order to support it. So yeah, that's a bummer.
Really interesting.
Yeah.
I know there's also vulnerabilities specific for precompiles, because sometimes when you do conversions on addresses using precompiles, you get funky results, right?
So yeah, the biggest problem we had was with delegate calls. Here, actually, the thing is that people like messed up really badly, because like on Ethereum it's really easy. If the address you are calling is precompile, you are branching out, you are using the totally different part of the code. If not, then you are going through the normal path, you are then applying delegate calls and everything. But the people believe that they are smarter on different EVM compatible chains, and they merge the logic. So you had the same logic for precompiles and any other code. So that's why you were able to do delegate call, which just gives you the parent context, and they were able to call the precompile with their parent, with their caller. And that was the source of all evil, because, for example, many chains have ERC20 as precompile. So now you could approve your ERC20 as color. So for example, if you had any AMM or any DEX, right? Then you just could call back from the DEX and use delegate call to approve, for example, tokens as the DEX. So many protocols were screwed by that.
Amazing and crazy stuff and what you think about. Chris, you ready, or should we go for Delirious?
Go for the Delirious.
Awesome.
I have
Delirious.
something that I can play.
Awesome. Feel free to share your screen, bro.
Okay, let me share my screen. Hopefully it's not Pornhub.
You haven't seen me on
Just
the side.
joking. Okay. Can you see my screen, guys?
Yeah.
Okay, so we worked using GitHub. So at the beginning, we decided to go with the thing that all the leads we have, no matter if they are correct or not, we will be using like using issues. on GitHub, they are really convenient. You may add specific labels to them. You can assign people, and I believe that it like turned out pretty well for us. So, for example, we had like many issues that turned out to not be valid, so we closed them. But we reported 3 mediums here. So, yeah, for example, this JB delegate uses like there are 2 options. You may either mint the project tokens or go through the swapping them on the Uniswap v3 pool. The thing is that if the Uniswap pool price is better, you're going through, and you want to do this, you are going through Uniswap swap. If not, you are just minting them. And the thing here is that nowhere here the protocol uses deadline. So if anything changes, so for example, let's imagine the situation that you put your transaction and I don't know, the fees goes up and your transaction is stuck at mempool. After 3, 4, 6 hours, it finally gets to be executed, and now the price is way different, and probably it is not at the rate that you would like it to be, and it got executed. So normally those issues are considered as mediums, so we added it as here as well. Yeah, so this is the first issues of them. Oh, second issue is actually quite interesting, and I will maybe briefly describe.
Hello.
Hello. Where was it? Oh, okay, it was here. Okay, so as I said before, there are 2 paths. If you want to swap, you are using Uniswap v3, and actually they are doing the try catch, which if this call, the pool swap, fails, it goes through the catch. So, and actually the amount received is not initialized here, so it will return 0, and in the calling function of the swap, the logic is okay, just a moment. Okay, the logic is if the amount received is 0, which is that means that it fails, like go through mint function. And this is not ideal because this may be forced to revert. For example, one case, it is like, in this case, it was like not possible. However, you have to know that, for example, this try can fail due to the out of gas. So you may give specific amount of gas for your transactions because only 63rd part of the gas is being passed through this external call. So there may be situations in which this call fails. However, and because out of gas, because you provide as little as possible, and it goes and finishes transactions because the gas is still left like for this call. So we thought that in this case, like it's probably not an issue because like this is the user who executes this swap, and for themselves. So they probably don't want to do this because it gives them nothing. It only gets in this path if it gets them more money than minting. So probably not an issue. However, like there might be issues. For example, there are not enough amount in the pool, and we are like going overboard. Or is there any issue we wrote that can be failed here? I don't think so.
I think we put two concepts of how this in the submission. We put two concepts of how this can affect the user. So one would be what Delirious said, when a Uniswap V3 pool has, so for example, the project owner, he adds the tokens to the Uniswap V3 pool and the price is very favorable. So a lot of people jump into the transactions to contribute to the protocol, to support the protocol and so on. But the liquidity in the V3 pool is not sufficient to withstand that demand. So at some point the swaps start failing. And users who jumped into that contribution transaction due to the price that is favorable will automatically get executed on the minting path, which is not necessarily the path that they will, which is not necessarily the price at which they would be willing to get this token. So if they would actually want to execute that transaction, they would have to go just through the swap directly, because otherwise, if they want to purchase, in that case, if they want to purchase the transaction in a tighter range that is a bit more favorable than the minting price, in case that fails, for example, due to liquidity shortage, it will automatically revert to the minting price, which is not necessarily something that a user can potentially want. So that was one scenario. And the other scenario was similar, I guess, to the is combined with the lack of deadline in the swap function. So if in case that the transaction gets caught in the mempool, and then the price of the token changes over time, and it falls below the minimum amount that the user provided. So imagine that there is a favorable price right now for the swap. So as I want to contribute, I put the limit at somewhat over what I would get for minting it directly through the mint function. So there is a space between the mint price, and the price at which I'm willing to buy. And over time, so my transaction gets stuck due to high gas fees. And in the meantime, the price drops, but it stays in the space where if I executed a swap at the current price, I would still get more tokens than from minting, but I will get less tokens that I've put in my minimum amount that I want to receive. So in that case, as the swap reverts and executes the minting path, I as a user, I incur a loss because of the fact that if I put the swap just right now, I would still get more tokens that I'm getting through the minting because my swap failed due to stale price.
Interesting. So minting incurs a loss on users.
Well, guys, if I understand correctly, the way to exploit this is one, by limiting the gas amount and by manipulating the call data, right?
So as I said, in this case, it's not beneficial to message sender. So yeah, this is an example. So if you see anytime this try catch, you have always to think, what if you pass the specific gas amount, and you can fail then the transfer this path force failing it. Sometimes it gives great results. In this case, like it's not practical because user would have to, grieve themselves, which like no one does. So yeah, but then to cut a long story short, the issue is here that if for whatever reason, lack of liquidity, stale price, or anything, user does not get what they want because they want to have like cheap tokens, the transaction is not reverted, but they are getting the tokens on non-favorable price to them.
I guess the only way that this could be exploited would be through a phishing contract that would write that function so the user gets screwed by some bad actor, right?
So, one simple action here is to sandwich this call. And so you are, driving liquidity really low, user executes their transaction, and then you are backrunning them, and they did not go through the swap path, but it failed here, so they use the mint path.
Very interesting, bro.
Yeah, and this is actually, I have a hinge that something might not be there because, like, as always, like, there are two cases here. Like, first, I thought that it's possible to have leftovers here that in case that this not all the data amount value is being used, some of the user payment in Ether will be locked in this contract. This turned out not to be true. However, I had this other idea that in their swaps, they are only using 0 for 1. This indicator, in Uniswap v3, it's required because the two tokens in the pool have to be ordered. So the token which has the lower address value needs to be first, and the other has to be second. So if you are doing that, and you are swapping, you have to pass whether you are swapping the token 0, which is the lower one, for the higher, or the other way around. So, yeah, but actually in their tests, they are like really hard-coded like JBX and WEF. So in this case, this address, as you can see, it starts with 45, so it's way lower than C0. So they are only testing this one path when 0 for 1, I believe is true, but they never test the opposite side. And I was thinking, so if there is no possibility to have this amount here, what if we swap? We use different tokens because the project tokens may have like way different addresses. So what if the address comes that is higher than this WEF contract? Will it still hold? So yeah, so I believe that Savior performed this test. It was like really hard for us. He did this test that shows that they are leftovers actually, but it was hard for him to do it on their test case because, as I said, like everything is being hard-coded here. They are even hard-coding mainnet URL together with the block number, which then we tried to test it like 1.5 hours before the contest ended, and we spent all this time, and I was fucking unable to make this thing work. So we said, okay, never mind, let's push it and we'll see. But yeah, the tests were really, really bad concerning it. And really, like, if this is because like I am like 80% sure that it might be the case. So if it is, then it's like probably serious issue because you are losing money here. But actually, it is serious, but it's just a leaking value. So leaking value is always like medium because you are not like stealing anything from user. They are just like leaking what they're sending to the protocol. Yeah, so those were our mediums. I think that every like low is added here. So
no highs.
No highs from our. We had some like ideas, but many of them did like just turned out to not be true. Okay, like as always, they are not checking for zero address, which is a bummer because like taint analysis is it should be always done. The taint analysis is just verifying like you treat all your data as tainted, and then you are using this what is called sinks, which is just you are conditionally checking if those values are in the range that you expect them to be. And this is called taint analysis. You are analyzing the data and making sure that at the moment that they are changing anything in your code, they are clean. And they are not doing that like basically anyone, like many protocols don't do that, which is like stupid because yeah, you deploy it only once. So I don't know, like four ifs will not add up to like really high gas costs for you. Okay, so this is additional law. So in their documentation, they're stating that their JB tokens are not compliant with ERC20, thus they cannot be used in any AMMs. However, in the code, we see that JB token it's actually ERC20 votes by OpenZeppelin. So actually, it is. So yeah, we just pasted it here. Oh yeah, and actually they're putting here like a pool, which the Uniswap v3 pool is generated for each market, and actually they're not verifying if this pool holds inside this WEF and their project token. You can do that using Uniswap v3 pool manager, I believe. So if you have the specific function that you can get back the address of the pool there. But yeah, they are not doing that, and like mistakes happen. And actually, the juice box has like 4 postmortems. They fucked up many times during deployments. So better safe than sorry. So yeah, those are all the issues we actually pasted. We had some hinges for example, that you may have like 100% loss because like minimum received from swap is based on slippage. Slippage is actually set on the front end and passed to the smart contract. So if for any reason the slippage is 100%, you can be sandwiched and get nothing. However, later I find out that they're just verifying if the price you will get from the Uniswap will be more favorable than minting them. So it invalidated this finding. What we had. There was like really interesting thing here. So they have like 2 main contracts. First is pay params, and second one is did pay. So they are setting the storage variables for minted amount and reserve rate here in this function, and they are reading that in the second function. And actually, this function is not protected, so anyone can call that. So right away, our idea was, okay, so clearly if you can re-enter then you can like change these pay params and make it here to like be like some super crazy amount. However, like we were not able to weaponize it in any way. So having known that the ERC20 is only like JB token and it's okay, it's not reentrant, we did not find any exploitation path that would lead to reentrancy and calling it again with your malicious parameters.
But if I'm not mistaken, that's because you need to know the initial code data to actually put in the function. And the thing is, for you to put that, as I can see below, it's actually been encrypted and then it get decoded into the ABI in the same function. So you need to have the actual encrypted information to do that. You see that? Literally where your mouse is above. Literally where your mouse is below. One below.
Okay, where something here?
Over here, yeah. You see,
here.
it checks it and it decodes the data. If you have the encrypted data, then you'll probably be able to code it. But you need to encrypt the data the way they actually encrypt it.
Yeah, but the metadata. But the metadata uses quote and slippage, and we are using this minted amount and reserve rate. So those are like different different parameters here. Yeah.
But it also requires you to be the terminal. Did you manage to bypass that?
Yes, like this function definitely. However, those two parameters are set here in this function, and you have like here no checking who calls it.
Yeah, but it's still encrypted data, so you still need to have that.
But if you were able to re-enter, in any way from the calling function, you can go between calling pay params and executing didpay and change those two values.
I can see what you're saying here because we were working at the same function for a very long time. But we came to the conclusion that it's not possible to break it.
Yeah, we had the say. Yeah, we as I said, yeah, we closed it because we also did not find any issue. Maybe we could like just create a law and say that you probably want to guard it to only JBX terminal because JBX terminal is calling it. But yeah, we decided to not go this path. So this was that was slippage and just hard-coded decimals. So I think that from our just let me go. If anything more interesting that we have here. Okay, this is what I actually said. Just a moment. Okay, this is about the leftovers. So this is duplicate. So yeah, this is more or less like what we found and what we think that is valid and turned out not to be valid. So yeah, given that it was our first contest and like there were like 4 days, but the weekend in the meantime, I think that we did like pretty well. Yeah, let's hope that the perennial that we are doing now will be even better than this. Yeah, let's see.
Really
so
nice.
guys, who else did this juice box contest? Sorry, I didn't register the name, but someone told that they were doing it, if I got it correctly.
I think Chris did it, but did it by himself, right, Chris?
No, I haven't.
No, so I think someone else did it, but they did it by themselves because I think it was a smaller code base. So they just went to Yeah, Chris, let's go. Very nice, Darius. Thank you so much for the amazing presentation. And Chris, let's go to see the findings you guys had. Can be Chris, can be also anybody from Red Lotus. Doesn't need to be Chris. Could be anyone else. Okay.
Do we simply like go through the findings that we have compiled in the report, or what?
I mean, you can go through the findings in the report, and you can also show the findings you have in engine layer and Anja. Okay. Ajna, actually.
I mean, we can start with Deegan layer, but like, yeah, let's go ahead.
If you don't think it's relevant, if you don't think engine layer is relevant, just go to something that you think is nice to show, and let's take a look.
I mean, like, both of them are kind of like big code bases, so there will definitely be some more niche findings, like things that will not be very applicable to other contests.
Let's take a look anyway.
Yeah, is my like Discord clear and stuff? Like,
Yes.
can everyone see everything fine? Okay. So essentially, can I like pull it up in a better way? Like, let's search JavaScript. Yeah, better. So essentially, this is the Egan Layer report that we did like almost a month now. How long has it been? Like, Miss? Maybe a month.
Around 35 days, something like that.
Yeah, it's kind of old, I suppose. But yeah, so for a little context beforehand, Egan Layer was essentially a restaking platform. So you basically have like LSDs, like liquid staking derivatives, like normal ETH and stuff, and you simply give it to the platform. So they essentially have your money hostage, and then you start like validating transactions, or like simply collecting APY, collecting like some yield and stuff. I mean, it was a very complicated protocol, but we still managed to pull off something. Huge props to that whale. So this is the high finding that we managed to get. It's essentially a donation slash share vector. I don't really know how to explain it in a better way. So essentially, the whole thing that happens is basically users doing a combination of taking money out of the system and also diluting the shares through donations and stuff regarding that. Because Egan Layer was using a vote of assault for like keeping their like the ETH. Here you can simply say see that the explanation that we have given is that the first time that you like invest money in the protocol or restake it, I suppose, it is on a 1-to-1 ratio to like the shares that you get. Then a malicious user may disrupt this balance via a donation attack, which is essentially donating money to the contract without actually getting any shares for it, which then like makes the price of each share more expensive, because the way each share is calculated is by like saying what the reserves in the protocol are, and then dividing it by the amount of shares. So then you get like the price per share. Then we see that after this donation attack that was done to the first user, the shares will be given one less per token. Then the strategy moves funds outside. This is essentially when a operator allocates funds outside of the protocol so they can be used for securing another I suppose contract. How are they called? I think they are called pods. So essentially, it is external functionality that relies on the security that the restaking protocol provides. This again can be front run because it is a normal transaction. When this happens, the strategy essentially what actually was happening here. Then the strategy moves funds outside. This can be front run, and essentially it's basically a combination of the funds dilution and the one-way attack, I believe. Yeah, this is the example provided that the people at LOTUS created. Essentially, we have three users: Alice, Danny, and Greg. Alice deposits 100 tokens. She has one-to-one shares to tokens, so essentially 100 to 100, because this is the price per share, 1-to-1. Then Alice decides to donate 900 tokens, which, as we said before, makes the price per share 10-to-1, because when you divide 1,000 tokens by 100 shares, you get 10. Then another normal user, Danny, doesn't notice this and deposits 100 tokens and gets 10 shares instead of 100. Now the system has 110 shares and 10 tokens, and 110 tokens and 110 shares, which is again a 10-to-1 ratio. Then Alice withdraws her 100 shares, essentially claiming her 1,000 tokens. Now the system has 100 tokens and 10 shares, which is again a 10-to-1 ratio. Then Greg moves the tokens outside of the ecosystem because he is authorized to make the money essentially get leveraged for security purposes. Now the system has 10 tokens because the money got deposited into another secondary protocol, and it has no shares. It has 10 shares because Danish shares are still there. Then Alice deposits 1,000 tokens and gets 1,000 shares. The system has 1,000 tokens and 1,010 shares. 1,000 for Alice and 10 for Danny, as we said before. And then Greg moves the money back into the strategy. Now the system has 1,000 tokens and 1,010 shares, which is effectively, if we can calculate that, I don't know, I'm not good at math, man. 1,100 divided by 1,010, which is this? 1.08. So it's essentially 1.1-to-1 in terms of the share price. Then we've got Alice withdrawing her 1,000 shares, and she gets 1,089 shares because the price per share is 1.89, 0.89, I'm sorry. And the system now has 11 tokens and 10 shares. Danny withdraws his 10 shares for only 10 tokens. But as we can see here, he deposited 100 tokens for 10 shares. So essentially, leveraging that funds were deposited out of the ecosystem, Alice managed to withdraw her 1,000 shares at a time where the share amount was overinflated, but the share price was a little inflated, but it was very close to what it actually was supposed to be. So essentially, the whole problem stems from the issue that the shares that are deployed outside of the system aren't accounted for in actually calculating what the share price is. And then Danny, as we said, withdraws his 10 shares and only gets 11 tokens. And essentially he lost 89 tokens. Which is basically what Alice managed to get as a surplus. Then here is a simple, not so simple, Foundry POC. Lots of log, lots of other stuff, and essentially it should not use the actual balance of the tokens that it has, because as we said, funds can move in and out of the system, which can create a discrepancy between what the system actually has and what is in the vault at that time. So essentially the solution to that would be to simply make some variable and like account for the tokens there. So like every amount of funds that is outside of the system can be accounted for, so no such things happen again. If funds move to a lending pool, it will not affect the calculation of shares. Also, the funds won't be lost due to LP tokens held by the strategy. But again, they need to be accounted for. And for donations, yes, we can also have a tracking variable that increments every time the protocol receives a donation. Then we've got H2. I'll just ask for something. Does anyone have questions regarding the first finding?
I don't think so.
Okay, then let's move on to the second one. Let's see. Then we've got the second high vulnerability. I believe we managed to disprove this one actually, but I will still like present the thesis that we've had. Essentially, the owner cannot freeze and thus cannot slash queued withdrawal that has a delegated address being set to the 0 address. So the protocol has a system of delegating your shares to another account, which is a verified operator who can actually perform operations in your name. So essentially, operators in this protocol are like validators in a normal blockchain. They essentially say what is right and what is wrong, and either get like rewarded for it or get slashed for it, like normal, let's say, proof of stake system would do. Like you essentially stake some money and then have some voting power essentially for that, and you can essentially dictate what's happening, but you get like punished if you try to be malicious in some sort of way. So the whole exploit stems from that. And then the issue is because of a check, I believe. So there is a can slash modifier which checks that the block number is less than the what was it? This, I believe, is the amount of time that is set to allow the user to actually withdraw their money afterwards, after they request a refund of the money, which will be 0 because yes, the user has not delegated to an address, because essentially you can the operator delegate scheme is a opt-in thing. You don't need to actually do it. It is entirely optional, but if you do so, you like essentially allow someone to use your capital for like validating stuff. This will revert the freeze operator function and will not allow the owner slash watcher to freeze the address, and thus will not be able to slash a queued withdrawal. This means that the user may act maliciously and then wait for the full 7 days before doing a full proper withdrawal. In the meantime, they can be slashed. They cannot be slashed, I'm sorry. So essentially, do we have the code here? No, we don't. So there was a check which essentially it was a for not for, it was a if statement, which checked whether the user is delegated, and if they were not, they couldn't be proceeded to the slashing part of the function. So essentially, if you are not delegated to anyone, you couldn't get slashed because the code was reverting beforehand. But then we dove deeper into what the protocol was actually doing, and then it became apparent that actually this is an intended behavior, because people who are not delegated to anyone cannot actually do any validating work. So essentially, we disproved that, but I believe we actually sent it. I'm not sure. I need to ask the other people. Here is a simple, not so simple Foundry POC. And then we propose a simple check to check that the delegated address is the message sender upon staking, or alter the can/function so you can freeze the zero address, which, as I said, is not a valid function. Then the other findings aren't very interesting. Like it is essentially not spec, and again not spec. So essentially, we found typos and some other wrong not spec that was in the protocol.
Really nice, dude. Really nice research. You guys did an amazing job. Red Lotus and Black Panda are going wild. So, I mean, this is also really helpful for us to learn. So, thank you so much. Anybody else has questions or want to say something? Awesome. So, guys, I guess this is how we close our first finding presentation. Really nice to see what we saw. And let's keep on so we can always, get those to be bigger and learn more and more from those, okay? Thank you so much, everybody, and let's keep on working, okay?